Class?
Yes.
That's actually not bad. Pretty good. Okay. Now, I will tell you this is my favorite lesson. This is my favorite out of all this because it is rude. It is sarcastic. Because back in geometry, there was, when you're trying to solve for angles and using similar triangles and triangle proofs, you would have like side, 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 angle, side, angle, side, angle. What's the one you are not allowed to use? Don't be an angle, side, side. Because right now, we're going to be dealing with some angle, side, sides. Okay? And it's that, and it's not that person that didn't want to add extra cheese. When you paid for that extra cheese, you're over there at Chipotle and you're like, I want cheese. And they're like, a little bit here. I'm like, no, I'm paying for that cheese. Put some cheese on there. That's going to be double extra. No, just put the, no, anyway. But still, now, because if it's an angle, side, side, it is. And it is a special case in trigonometry. It's the ambiguous case. And if you hyphenated the word and you say it with like, emphasis in certain parts, because you have an angle, side, side, that turns into ambiguous. What type of triangle? It's ambiguous. It is the ambiguous triangle. But because it's ASS, it's ambiguous. Okay, so yeah. I know, right? It's like all 3-year-olds that they're like, ha, he said ass. Okay, ASS referring to not the donkey that Jesus rode in on, but the angle, side, side. So, right here, case of law of side. So we're going to do law of sines for this. But instead of solving for the side, which we did all in 7.1, we're going to solve for the angle. We're going to solve for the angle. Let's see if you guys remember this. If I'm looking for the angle, I do the inverse. Very good. So it's going to be the same steps, but that last step you're going to do is going to be the inverse to solve the angle. Let's start this off. Now, there's a whole bunch of blah, blah, blah here. And I'm going to explain to you what the blah, blah, blah is. So when we're starting with this, there is a possible to have 0, 1, or 2 triangles with the ambiguous case. Because just because you have a bunch of sides, 3 sides, it doesn't tell you, or it doesn't mean that those 3 pieces together is going to make a triangle. It's possible that it can make a triangle, but it's also possible that it doesn't make a triangle. And that's what we're going to be dealing with here. Blah, blah, blah. There's good reasoning. Blah, blah, blah. That. Blah, blah, blah. Okay. Now, all those examples in the blah, blah, blah doesn't make any sense until you actually do some problems with it. Because right now it's just a whole bunch of words on paper that have no meaning. Let's actually do this to see what it does for us. So the first thing I'm going to do, whenever I have one of these triangles, do I have a triangle up there? Say no. It's on your notes. You're on example 1. Flip the page. All right. Is there a triangle up there? No. So what do you have to do? Draw your own triangle. You have to draw your own triangle. So I have a standard, very generic triangle. I always do. I always do it in the same format. I know it's probably not to scale. It's definitely not to scale. It's just I need to know where things go. If I have big A is going to be 55 degrees, 40 minutes. Little b, oh, I'm sorry, I put it in the wrong spot, didn't I? Okay, so big B is 5540. And little b is down here, 8.94. Why do I know that little b is right there? It's directly across from big B, right? It's directly across from big B. And little a is 25.1. What line segment is little a going to be? It's BC. It's line segment BC. So it is on the notes, or not in the notes, it was in the homework. And a lot of people struggled because they forgot about the line segments of how they're named. So BC here is going to be my little a, which was 25.1 meters, right? Now, same rules apply. Do I have a pair? What pair do I have? I now have B's, right? What do I not know? I don't know little c, so I'm going to put that where it goes. So I don't know little c. I don't know big C. And I don't know big A, right? I don't know big A. But do I know little a? I do. I do know big A. So let's look very carefully at this triangle, what is given to me and how it's given to me. Actually, let me use orange. This is a what? Angle. So I'm going to call it an angle. So directly touching that angle, either you're going clockwise or counterclockwise, is a side, right? Which side is touching that angle? Is that little a? Little a, because that's given to me, right? That's how I'm using this. So that's given to me. So I go an angle. This is given to me, so there's a side. And now, do I have a side touching that side? Which one? Little b, right? Because it's touching that side, going here to here, right? It's touching at this point. That means that this is a side and side. I would not say angle side side if C is over here, if I give you C. That would not be that because they're not touching. Because A is not touching C. A is touching little b. So there is an angle side side. So that is a... It's a what? Ambiguous. So it is ambiguous. So there might be 0, 1, or 2 triangles here. That's just with the information given to me. So let's go through and solve for it. I'm going to solve for the angle. So starting out, I'm going to start with what I know, which is going to be my B's. So 8.94 divided by sine of big B, which is 55 degrees, 40 minutes, is equal to... Now, am I going to solve for... What am I going to solve for here? What do you want to solve for? YA. Do I have side A? Do I have little a? That's very good. That's pointing out the important pieces. I have little a. I can solve for big A. But because I don't have little c and I don't have big C, both those together, I would have 2 variables here and it wouldn't help me out at all. So I'm going to use this to try and solve for big A. So it's going to be 25.1 over sine of big A. Yes? Okay. So let's keep going. So I'm going to go through, I'm going to do my cross products. I'm going to do the steps for all those people that decided not to show up recently. So cross products there. So I'm going to end up with 8.94 times the sine of big A is equal to 25.1 times the sine of 55 degrees, 40 minutes. Now, I'm trying to get big A by itself, right? Say yes. I'm trying to get big A by itself, but what's happening to that? That's in the sign, isn't it? So right now it's 8.94 is multiplying by that sign. So to undo that multiplication, divide both sides by Very good. Divide both sides by 8.94. So those cancel. I'm left with sine of A is equal to 25.1 times the sine 55 degrees 30 minutes divided by 8.94. Is A now by itself? No. Sine of A is, but A is not by itself. So if I'm looking for the angle, I need to do the, and when I do the inverse, my big A and that big pile of numbers over there switch places. They switch places. So now it's going to turn into big A is equal to inverse sine of 25.1 sine of 55 degrees 30 minutes over, I paused too much right there. It's annoying. Alright, over 8.94. Like that. So all that right there is inside my sine. Now we're going to plug this into the calculator here. So go ahead and plug this in, please. Please. So everyone plugging it into the calculator is important. Clearing it out. Alright. What mode's my calculator got to be in? Degrees, because I'm using degrees. Now, when I do this, it's important. So, I'm going to start with my inverse sine. And now, inside that inverse sine, what should I put? My fraction, my controlled divide. And then I put, what was the number? Times sine 55 degrees 30 minutes. No, DMS means that I want my answer to be in degrees, minutes, seconds. So I'm not doing that right now. So when I'm done, I would DMS. So if it says my angle is going to be 97.2, I would DMS that answer. Okay? Alright, and what was on the bottom? 8 point. There we go. And what do we get? Undefined. What do you think undefined means? There's no triangle. There's 0 triangles here. So that means that, because of that, this is not going to be a full triangle. Here is a diagram of why it's not a real triangle. Because little b is not long enough to actually complete the whole triangle, right? That's why. And it doesn't matter how long this bottom side is. If this is going to be 55 degrees 40 minutes, this is my angle from there to there, and that's actually a realistic. So no matter how long this is, it's not going to touch that. So there's a couple rules besides stay off your phone during my class to go along with this. So the largest angle goes with the longest side. So the largest angle goes with the longest side. So if big A is the largest angle there, little a has to be the longest side. So what's the converse of this statement though? What's the converse of this statement?
The smallest angle goes with the smallest side.
Very good. Smallest angle goes with the shortest side. This is going to help you out when you're doing these problems to look to see if it is going to work. All right, do we have this written down, or are we just still playing with our phones? Play with your phone or write it down? Oh no, there's people right now on their phones right now, but it's not like they need this to graduate. It's all right. Just remember when I'm, shouting at you guys from the stands. Now, this is where it happens. Ambiguous case, we're given two sides and an angle opposite one of the sides. So they say side, side, angle, but we all know this is angle, side, side. Okay, because you don't want to be an angle, side, side, because when we get an angle, side, side, this is the ambiguous case. So, ambiguous case. So, do I have a triangle here? What do I need to do? Draw a triangle. Please do that. Okay, so I'm going to make this one ABC. Very generic triangle. Let's start plugging in my values. So big A is 55.3 degrees. Little a is 22.8 feet. And little b is 24.9 feet. Right? Starting to get warm in here. Okay, I'm just going to point it this way.
Yeah.
Okay, thank you. Sorry. Now, is this ambiguous? Let's look. We start with an angle. An angle. The side that's touching it, right? The side that's touching it.
Does it matter which side?
I can go clockwise or counterclockwise around it. So this one is going clockwise. So there's a side, and then touching that side is another side. So that's an angle, side, side. Yes?
I have a question. Does the answer change if you have B at top and if you take the bottom, or is all of it?
It's just gonna, it's not gonna matter, because if you have B on top, then that means down here is your 24.9, right? Yeah, it's not gonna matter. As long as you draw it, I draw it. I drew it like this because I've been doing A, B, C on top. The diagram that they give you at the end of this is A, B, C, like this. That's the only reason why. Now, this one is angle, side, side. Because it would have been angle, side, angle if I give you big C here. That would have been angle, side, angle. And if I would have gave you little c, this would have been side, angle, side. All touching each other, side, angle, side. Because the side, the angle's between the other side. And that goes back to geometry. I'm not gonna like harp on that too much. Just you need to know the ambiguous case. All the rest of it goes exactly the same as we've been doing. Now, do I have a pair? I have a pair what? What pair do I know? I know the 8, so let's start with there. So it's going to be 22.8 over sine of 55 degrees, 55.3 degrees, sorry, equals. What do I have to solve for first? Big B, right? I have to solve for big B because big C and little c are both unknown. Big C and little c are both unknown. So I only can solve for big B here. So I'm going to set it up. 24.9 over the sine of big B. So, do your cross products. Do your cross products. Cross products this way, cross products this way, and we get 22.8 times the sine of big B is equal to 24.9 times the sine of 55.3 degrees. To get sine by itself, I'm going to divide both sides by 22.8. So sine of big B is equal to 24.9 sine 55.3 degrees over 22.8. Am I looking for an angle?
Yes.
So whenever I'm looking for an angle, I do the inverse. There's a reason why I've been saying this all year long, back in since like unit 1. If you're looking for an angle, you do the inverse, because I promised you way back then, we're going to be doing the same stuff over and over and over again. It's just putting it together in a different way. So we're doing the inverse because we're trying to find the angle. So big B is equal to inverse sine 24.9 sine of 55.3 degrees over 22.8 there. Now I'm going to plug into my calculator. What was that first one? 24.9, right? Oh wait, I didn't do my control divide. Sorry. Control divide. There it is. 24.9 sine of 55 point. Oh, dang it. 20 what? 23.8? 22. Okay, there you go. 22.8. Like this, right? See? I'm glad you guys paying attention. You guys need to check me on these. Because sometimes I'll make, listen, sometimes I'll make mistakes on purpose. This isn't one of those times though. It's not one of those times. Hit enter and we get 63.9. DMS?
Right.
Okay, so why would I not?
Because it's a point 3.
It's decimal degrees, right? If I would have had an answer on the previous one instead of undefined, that would have been DMS.
Oh, so if you have the minutes and
Yeah.
With the number, you have to put DMS?
Yes, you do DMS. But this one right here is already in decimal, so I leave it as decimal. So my answer is going to be 63.9. Okay? Now the problem with this is that
The longest thing, you don't have the thing you think.
okay, so
Yeah.
now try to say it with less thanks.
The longest, the largest angle don't go with the longest. Oh, yes, it does.
But the problem is we still don't know.
Yeah, we don't, we have to get.
Yeah, 'cause we ain't got the C.
We don't have the C's, that's why. So now, so this is what you do. Because this one is an angle side side, this is ambiguous, we have to look to see if there's two triangles. And that's where you, because it's angle side side, this is the next step you do. 180 minus, what was it, 60,
3.97.
right?
Yes.
Like that. What's that going to give me? What is it? Point. If this right here, we come up with this. This is how you find out if there's going to be a second one. So we know all three angles in a triangle add up to what? 180. So now I have to test this. I have to test this because I know that angle A plus angle B plus angle C equals 180, right? So I'm going to say angle A. What was angle A? 55.3, right? Yes? Angle B, which is going to be the second angle, because I'm going to call these all second if it does work out. So put 116.1 plus angle C is equal to 180. Now, how would I figure that out? If I just want to plug that straight in my calculator, what would I do? I would do 180 minus 55.3 minus 116.1, right? And if I get an answer that is positive, there is a second triangle. If I get an answer that is negative, there is no second triangle. So please plug this in the calculator and tell me what you get.
Okay, so we did that like 180 minus.
Yes, that's because ambiguous. That's B2.
Right.
So whenever I do this and I have an ambiguous case, like we do here, right? You test it like this. When I'm finding the angle, whatever angle I get first, like I have right here, I have to take 180 minus that angle. And this angle is going to be B1, right? So this angle is my B1. So that's, if there was only one triangle, that would be B from that triangle, right? But if there's two triangles, I would have a B from the first triangle, and I would have a B from the second triangle. So there's a possible being two triangles here. What did we come up with here? So we said angle C is what? What is it? 8.6. Now, is that positive? So what does that mean? There is two triangles now. Because this is a positive number, there's two triangles. So my triangle is now going to look like this. It's all cattywampus here. So this one was 55.3. This is 116.1. And this one right here is going to be my C, which is 8.6 degrees. This was, and that's A.
Why did the A fit
Because A is A. We didn't solve for it, did we? That's given to us. So that is a definite. A is that value. But since we're solving this and we're dealing with an ambiguous case, an angle side side, we're going to have two triangles, and it's going to look like this. So this is my triangle 2. What other value was given to us here? Little a. So what was little a? Say it again. What other value was given to me? Little b, right? What was that?
Wait, oh, no, that's little b.
Oh, that's little b? Okay.
A is 22 to 8. And then little b is 24.
Right? Because of how this works out, there is ambiguous. It's two possible triangles. Do I have any unknowns here also still?
Yes.
What do I have?
Little c.
Little c. So we're going to do law of sines to get little c. And that's going to be little c 2. I'm going to come back to my problem on the other page to find the other values. Because I'm still going to have to find all of it. I'm just going to have to find all the values for the angles and sides for both the triangles. And trust me, on the homework, there's not a bunch of these. I think there's only like 2 or 3 that are actually two triangles. I know it's, but this is basically 2 problems worth of work for each one of these. So that's why I'm trying to limit the number of these that you're going to have to do. So let's go ahead and do the law of sine again. Start with what I know, which was given to me, which is 22.8 over sine 55.3 is equal to, now if I'm looking for c, that's my variable, right? It's going to be c2. I'm going to call it c2 because there's 2 different values for c. And we're going to go back and find for the first value here in a moment. I just want to make sure we're filling all this in as we go to explain why it's like this. And then this is going to be sine of 8.6 degrees. So we get little a, or little c, sorry, c2. So I'm going to use the pattern. So we said c2 is going to be, what's that going to be? That's 22.8 times sine of 8.6 degrees over sine of 55.3 degrees. And we plug that in. We plug it in. I'm trying to be a stickler about actually plugging into the calculator, because once it comes down to doing it, the actions of actually plugging it in, because I have people in my other class that won't do that. They'll just pick their nose and look at me while I'm going over this and get mad at me come test time when they have to learn how to put it in the calculator at that moment. What do we get? C2 is going to be about what? Was it? 4.1. Does that make sense? So it'll make even more sense here in a moment. Go back to the rule that I said. Largest side, largest angle, right? What's the largest side here? The 24.9. So what's my largest angle? Okay, so it's going to be B, right? The smallest side? It's going to be C here, right? And smallest angle. Those go together, don't they? And the middle's the middle. That's important. So now I'm going to finish the first triangle. Because over here on the first triangle, we have these 2 values here, right? Yeah? Okay, so now I'm going to copy this over to the next page. So we can, because this has all my work for this, I'm going to copy it over so we can do it again. So my triangle, what do we say, 60 what? This one was 55.3. 20. And this one is, there we go. So this is the first triangle here, right? So this is my B1 and my C1. So B1 and C1 are here. Now, I also have to find little c1. So using these values here, all three angles have to add up to what? 180. So let's go ahead and solve for C1. So I'm going to say that 55.3 degrees plus 63.9 degrees plus C1 is equal to 180 degrees. Please map that for me. 60.8. So you're saying that C1 is that. Now, this is actually one of the keys here. Now, which one is the biggest angle? B is the biggest angle here now, right? Okay, which one's going to be the smallest angle? A is now going to be the smallest angle, isn't it? So, with the two different triangles, it changes those. So, can we still solve for C1 now? I'm going to do that again using law of sine. So, law of sine, so it's going to be, let's see, go with what I know, 22.8 sine of 55.3 degrees is equal to C1 over sine of 60.8 degrees. Do my steps. C1 is equal to 22.8 sine of 60.8 degrees divided by sine of 55.3 degrees. So C1 is what? 24.2? I'll let people actually plug it in. What do you say, 24.2? And my units here, I believe, are feet, right? Yeah. Now, does that work out? Is A still my smallest angle and smallest side? Is B still my largest angle and largest side? Yes, it is. Whenever you have one that comes out to an ambiguous case, you're going to have to look for two triangles. And that's whenever you have the angle side-side. Yes? No? Maybe? So here's the diagram here with everything filled in. That's the reason why we can have two separate triangles off of this. Because for this one, for little a, could go that way or out, kicked out to that way. And so that means it's going to change my value on C's. Yeah, that's it. All right, so I'm going to leave off there. I'm going to let you have the rest of this class to try to get as much of that homework done. Don't forget the 7.1 is, I changed the due date to today. So please make sure you get those done. Like, share, subscribe, hit that notification button, and